Alright, today we're going to start talking about exponential functions. What you need to know about exponential functions is that the exponential function is actually the inverse of the log function. So ln of x and e to the x are inverses of each other, meaning that they're symmetric about the y equals x line. One of the next things I want to talk to you about is how to find the derivatives of e's. The derivative of e is just simply e to the x. Or the derivative of e to the u is e to the u, and then you take the derivative of that exponent. That's where that du over dx comes from. So that's when you have a more complicated exponent other than just x. So if you have x squared or anything like that, you would take the derivative of the exponent. What we're going to first start by doing is reviewing how to solve for x in e or ln functions. So this first function, I have e to the ln. That makes it actually pretty nice because we need to remember that e and ln cancel each other out. So I can simply just write that 2x is equal to 12. And then I'll divide by 2 on both sides, and I get x is 6. So that is my answer for that problem. On the next problem, I don't have the e and the ln. So what I'm actually going to do is I'm going to create the ln on both sides by solving for e. So I'm going to get e all by itself here. And then what I'm going to do is I'm going to ln both sides. So when I ln both sides, what that does is it creates an ln and an e, and it allows me to cancel. The reason why you can cancel is because you're actually using the log rules, and you're bringing the x out front. So you're creating this ln of e. Well, the ln of e is actually equal to 1, and so that's why it does cancel out. And you get x is equal to, I've already typed that in the calculator, let's hit enter. We're supposed to round it to 3 decimal places, so 3.033. So we'll go back here and we'll write our answer as 3.033. Let's do one more of those. This one has an ln. The ln. The way I'm going to do that is by e'ing both sides. But before I do that, I can actually pull this out front using log properties, which will actually simplify the problem just slightly. So what I'm going to do then is divide by 2 so I can have the ln by itself. So I have the ln x minus 2 is equal to 6. What I'm now going to do is I'm going to write e to the ln of x minus 2, because when we e both sides, we're actually raising it to a power. Those cancel, and I have x minus 2 is equal to 6, or e to the 6th. Let me make that correction. And then the last thing I would do is write x is equal to e to the 6th plus 2. Now, you should, on your calculator, be able to find an e. So it's just be e, and it would have it to a power probably automatically. I need to actually raise this to the power. I need to figure out if I can find the button for it, which I'm not finding, so, oh, there it is right there. Raise it to the 6th power, and then plus 2. So I get the answer of 405.429. So 405.429. That would be out to 3 decimal places. Continuing on with this topic here today, the next thing we're going to do is talk about using a graphing calculator to graph e to the x. And then we're going to look at how all of these are all related. Now, I'm not going to actually graph those on a graphing calculator. I'm just going to go ahead and simply tell you that you can do it on your graphing calculator and what e to the y equals e to the x looks like. So, if I plug in 0, I get e to the 0, which is a 1. This graph, if I was to plug in 1, I'd get simply e. E is a number like 2 point something or another. So this function actually climbs up like this. I am going to actually need to finish this in the next video, but I do want you to see what e to the x looks like. Alright, I have gone ahead and typed it into the graphing calculator so you could see what it looks like. Notice it passes through at 0, 1, and it is climbing up, and it's never going to cross over this x-axis. So, what does this part mean right here? When the x is being changed, that means you're shifting units right or left. Because it's a -2, we're actually shifting this graph 2 to the right. So instead of it crossing at 0, 1, it now will cross over at 2, 1. Everything else will remain the same. It's still going to be climbing, and it still will have that asymptote of the x-axis. On this next picture, if you have a negative out front, it reflects it over the x-axis. So if I reflect this over the x-axis, that now means that I'm at 0, -1. It also means that it's going to get closer and closer to the x-axis, going climbing from the left, and it's going to actually start decreasing. This last one, this is flipped over the y-axis, and the +3 raises it 3 spots. So if I go ahead and raise those 3 spots, I was at 0, 1, now I'm at 0, 2, 0, 3, 0, 4, so I know it's going to cross through there. You have to remember it's also being flipped over the y-axis. So the asymptote would have been at 0, but it's going to be 3 higher. So I'm going to go ahead and draw this line as the asymptote. It's being flipped about this y-axis right here, so this is being flip-flopped, and it's now going to be falling to the right instead of climbing to the right. The next part we're going to do is look at why these are inverses of each other. So we're supposed to illustrate that the functions are inverses of each other by graphing both of them on the same coordinate plane. Now I'll let you guys type those in your graphing calculators, and all I'm going to do is just simply sketch what you should end up with, or a picture similar to what you should end up with. So you should have a function that's climbing up like this, and then another one that's climbing over like this. What I want you to recognize, though, is when you put them in your graphing calculator, you should see that they're symmetric about the y equals x line. So that means that you could fold them in half over that y equals x line. The last problem we're going to work on is the only problem we're doing today with derivatives. So we're going to find an equation of the tangent line to the graph at 0, 1. Well, that means I need to know the slope. So I'm going to take the derivative. The derivative of e to the x is simply e to the x. We'll have a 2x. So I have to remember to take the derivative of the 2x, which would be 2. So I find out that the derivative at this point, 0, 1, would be 2e to the 2, and I'll put 0 in. So I find out that the derivative is just going to be 2e to the 0. E to the 0 is 1, so the derivative is 2. So this is the slope of my tangent line. The equation of the tangent line would be y minus 1 equals 2 times x minus 0. I'm going to do it one more time. This time the only thing different is now I'm doing it, finding the tangent line of the curve for e is the negative 2x. So that means my derivative would be e to the negative 2x, and then I'll take the derivative of negative 2x, which is negative 2. Then what I'm going to do is I'm going to figure out what the value is at this point. So I'll put in 0. When I plug in 0, I end up with negative 2e to the 0, and negative 2 times 1 is negative 2. Then I'll write the equation of the line, y minus 1, using this point, equals the slope of the line, and then x minus 0.